Hi everyone, in past lessons you learned how to find the empirical formula and they were giving you the masses, for example, for this and this. So in this lesson we will learn how to find it without they give us the mass. So we will find the masses, okay, by something called combustion analysis. So which mean combustion mean burn, which mean in chemistry adding O2. Okay, so for example, you have a compound CHO. So for imagine you have powder, okay, and you know it's contains C, H, and O, but you don't know their masses. So how do you find it? Scientists used the combustion analysis, which means they burn it, and when they burn it, we said that combustion means adding O2, right? So they burn it, which means adding O2, and it will always produce carbon dioxide and water. Okay, and this one will not change. Always when you use combustion analyze, you add O2 and it will always produce carbon dioxide and water. And you need to know it because in the exam they will not say for you it's produces CO2 and H2O. No, you have to know that in combustion always in combustion for the element CH, it will always produce carbon dioxide and water. So you say, okay, how we find the masses if we burn it? When you burn it, if you see that here we can find. So let's call the mass of Cx, mass of Hy, mass of O here Z. Okay, so you can find the mass of C from carbon dioxide because there is C, and you can find the mass of H from water because there is H. So you can find X from here and Y from here. So let's see how to do it, okay? So imagine you have no, not imagine. So there's steps to do that. So step 1, okay, let's you change gram to mole, okay? So let's start with this to find X, okay, or the mass of carbon. So CO2, to change min gram to mole, you need to divide by molar mass. So it says here, so you can see it's 4.40 gram. So 4.40 divide by molar mass of CO2, which you can find it from the periodic table, and I wrote it here, it's 44. So there we find the mole, which is 0.1. Step 2, you see how many how many you have from the carbon dioxide. You see how many carbon, like for example, you know that one carbon dioxide has how many mole? If there is one carbon dioxide, there is 0.1 mole, right? Okay, then you see you have just one C, right? So it will be 0.1. Like, see, for example, if C was 2, then this will be 0.2. Why? Because one carbon dioxide has 0.1, but there's 2 carbon, so you double it, okay? But now we have just one, so one carbon dioxide, 0.1. You see there is just one C, so it will be 0.1, okay? Step 3, you return it from mole to gram, which means multiply by molar mass. So the mole of C now is 0.1, right? You multiply it by molar mass, which is molar mass of C is 12. So multiply by 12, which equal to 1.2 gram C. Okay. So see, we found the mass of C. It's kind of long, but it's easy steps. So we find the mass of C, which is 1.2 gram. So let me retrace steps so you understand. First, I will say you change gram to mole. Like you have CO2, right? You change it to mole. So then in step 2, you know how many mole in C, not in CO2. So if you have one CO2, 0.1, and in it there's one carbon, so it will be 0.1. If there was 3 carbon, so it will be 0.3, like that, okay? Then you return it to gram, and just like that. And you do this for the H also. So let's find the H first, okay? So you have H2O, right? Gram to mole, we divide by molar mass. So it's already 3.60. So 3.60 gram divided by molar mass of H2O, which is 18. Okay? And it will be, then you will find out it's 0.2. Okay? Mole of what? Hydrogen, of water. Okay? So how many mole of just H? It's 0.4 mole of H. Did you know how? Like, see, in one water, there is 0.2 mole. Okay, but there is 2 hydrogen, so you double. Okay, you double it. If there is 3 hydrogen, it's 0.2 multiplied by 3, like that. So it depends on how many the hydrogen you have. Okay, so there is 2 hydrogen here, so we double. So there is 0.4 mole of hydrogen. Then you return it to gram again. So 0.4 multiplied by molar mass of hydrogen, which is 1. So it's 0.4 gram of hydrogen. Okay. So now we found for the hydrogen. Okay, it's 0.4. Okay, now you say, what about the oxygen? What about the oxygen? Now, after you found out the mass of C and the mass of H, so you have, like, it says in the question, if you read, it's the sample of compound. It's the sample, all the sample. So C, H with O, it's all equal to how much? 3.20, right? So you know that C is 1.2, and you know that hydrogen is 0.4 as we found, right? So what will be the oxygen, right? So you just add them, and you minus C and H from the total, so you found O. Like you know that it will be all when you add it all, it's equal to 3.20, because it says from the question. So you add 1.2 plus 0.4 plus O, it will all equal how much? 3.20. So this is 1.6, okay, plus O equal 3.20. So you will just minus 1.6 minus 1.6, okay? So O is how much? So it will be 1.6, and that's it. Now you have all the masses of each element And now you can find the empirical formula easily. Like, it's easy. So you know that mass of C is how much? 1.2. And mass of H is 0.4. Mass of O is 1.6. So easily just divide by molar mass. So this divide by 12, this divide by 1, this divide by 16. So it will be how much? 0 0.1, 0 0.4, 0 0.1. Then divide by smallest, 0 0.1, 0 0.1, 0 0.1. This you talked before, how to find the empirical formula. So it will be C just 1, H will be 4, and O 1. This is the empirical formula. I hope you understand. And if you have any question, I'll be glad to help you. Bye.